I welcome all of you in this video. This video is regarding normal distribution, and this is the second part of this video. Okay, in the first part we have discussed about normal distribution, its properties, and we have solved few problem in which we have calculated the probability data associated with specific z values. In this video, I will calculate few more problems. So we will start this problem. In this problem, they say that calculate the k. K is basically the z value associated with the probability on its right hand side is 0.3015. So first of all, I will write how we'll start. We know that this value z value is towards the right side of the mean value of the center. So we got the clue that the z will be positive. Why we got this clue? Because we have to check the tables, and we'll check the table of positive z value. And so what's the second one? The second thing is that the k is basically the z value. K is z value. We have to find this z value. Now the third thing is the table give us the value from the right side of this distribution till this point. So we haven't any clue of this z value. So what we will do? We know that from the right hand side till another end means the area under the curve is equal to 1. So we say that our area A1 is equal to 1. Then we will find out this area, that the area that is basically the white region, and we call it A2. How we will find this area? We will just only subtract. We'll say that A2 will be equal to this whole probability 1 minus this A2, and we can easily find out A2. We will subtract my 0.3015 from this one. Okay, again you see the large is 1 and this portion is 3.3015, and when we will subtract this region from this large one region, we ultimately result in this region. So we'll get 0.3015. Okay, so we will get A2. A2 will be equal to 0.9685. So what this value tell us, that the probability of this region of the z value suited with this region from this starting point left point to this point is, this region is 0.6985. Okay, so now we'll go towards to the book, and we will check the z value associated with this probability. But keep in mind that we will have to check the tables with of the positive z values. So by opening the table, we got this positive z value table. First of all, the value we need is 0.6985. We'll check where is 0.6. Okay, we got 0.6 there. 0.69 we need. So it's 0.68. This is the value 0.6985. Highlight it, and we got this the value 0.6985 at the intersection of 0.5 at the y-axis of the z and 0.02 at the x-axis. So it is obvious that we got k is equal to 0.52. It means that at k is equal to 0.52 or z is equal to 0.52, this is the value to the right side of which we got an area of 0.3015. I hope you understand this problem. This is second problem. In this problem, it is told that 0.4197 area has been given between 2 points. One of the point is minus 0.18, and the second point basically it is k, so it is unknown. It is basically our z value. Okay, so what I will have to do, I will just again make a few and get information. We'll gather information. First of all, both of the z values, minus 0.1 and k, is on the left hand side of our mean, or our you can say mu. So what is meant, that k will be negative. So we will have to check the tables of negative z distribution. This is the first point we have. The second point we have, how we will solve this problem. So I haven't any area that is starting from the extreme left hand side of a distribution. So what I will do, I will again find few areas and we'll do subtraction among them. First of all, I will calculate the maximum area from the left hand side till the z value or z value of minus 0.18, and I will call it A1. Okay, so I will check the area that is associated with A1, or that is associated with z is equal to z is equal to minus 0.18. So I will write here z less than less than 0 minus 0.18. So I will check the value in the table later on. Then I will check on the third point. I will check the area. uh, I will check. Now we have the probability of my 0.4197. So we have given this probability, and this probability is between these two points. So the clue is that we will subtract over 0.4197 from this area. Let me check this area from the book. So the value is issued with minus 0.1. This is minus 0.1, and here it is 0.8. So the value issued with these two values 0.4286. It is minus 0.4286. Now it will be quite easy for you people that we know that this area is equal to 0.4286, and you know the area between these 2 points is minus 4.97. This area is between these 2 points, and it is and the 0.4286 is from the left hand side till this value. So what we will do, we will subtract this A1, okay, A2 from A1, and we will get over this third value, that is A3. So we'll get A3, and then we will find this A3. This is basically the area, and or you can say probability, and we will then check again that what z value is associated with this area. So let me write, it is 0.4286 minus 0.4197, and we get A3 is equal to 0.0089. So this is the A3. Now I will have to check the z value associated with this area, and we will get over k value. So again I will go towards the book. Keep in mind that the value we are going to find is on the left hand side of the table. So we got this is 0.0089. This is the probability, and it is associated with on the left minus 2.3 and 0.7. So we'll say that minus 2.37 is the z value that is associated with this point. So I will write here k is equal to minus 2.37. So we have solved this problem. Now we'll move toward the third problem. So these are basically the problem that is associated with the statement. In this problem, we will use z formula to convert any value of the random variable x into, first of all, z values. Then we will check the probability or area under this value in the table that has been provided by the end of the book. So first of all, we have a random variable x. The mean of that random variable is 50. Its standard deviation is 10. This saying that calculate the probability that of a random variable x, it assumes the value that it will lie between these two ranges 45 and 62. So you can see that what are the clues. First of all, you will see that 45 our mean is 50, okay, and then you will see that over the 45 one of the value is less than this mean. It means that it will lie to on the left hand side, and we'll have to check in the negative z distribution table. 62 is greater than 50, so the z value will be positive, and it will be in the positive z distribution table. First of all, you will have to use the formula z is equal to x minus mu divided by standard deviation. So x is 45, mu is provided to you. This is mu is equal to 50, standard deviation is 10. You get z is equal to minus 0.5, and then we will use the same formula in order to calculate the z value for the second value of the random variable, that is 62. So we will subtract 50 mean from the 62 divided by standard deviation. I got z value 1.2. So you will write technically that we will have to find the probabilities that the random variable x, it lies between 45 and 62. So you will then transform these value of the x into z, and these two values 45 and 62, they have been transformed into z values. So what we will find, we will find the probability that are associated with the z values between 0.5 and 1.2. So this is 0.5 and 1.2. I will now go to the book for the z distribution values, and I will tell you that how we will calculate the area with minus 0.5 and plus 1.2. So minus 0.5 lies here. You will have to check in this value, and associated with this is 0. So it is purely minus 0.5. Remember, this value is 0.3085. Now we will move towards calculating the second value. Our second value was 1.2. So this is positive z distribution table. I will check in there. So this is 1.2 positive z, and this is the z. So I will check. This is 0.8849. I will maximize 0.8849. Again, we will go towards the presentation, and now we'll see that what values we got. So the value associated with 1.2, we will got this value from this left hand side till this point, and the value is 0.8849. Then earlier we have find the value of the area associated with minus 0. We got this area is as 0.3085. You will say we have to find this A3. We have 0.0049 as A1, and this value is A2. So what we will do, we will just say that A3 will be equal to A1 minus A2. So just subtract these values. That 0.8849 minus 0.3085, we got 5764. So A3 is equal to 0.5764, and we got our value A3 is equal to 0.5764. I hope you got this problem cleared. This is the second problem, that is related to the statement problems. So first of all, what we will see that it is a normal distribution the problem is. So we will use the formula of z is equal to uh, x minus mu divided by standard deviation, or we will use the standardized normal distribution tables in the appendix of your book. The random variable has mean 300, standard deviation of 50. I will have to check the probability that the random variable value, it will be greater than 362. So first clue, that our z value will be positive. Second clue, we have that we will check our value in the positive z distribution table, and along with that, what the problem statement says that we have to find the value greater than 362. So the problem is saying that calculate this region. Okay, calculate the area of this region. However, when we will calculate the z value set with the 362, for that z value in the table will give us value from this left hand side till this point. So what we will do, we know that the area under the curve, or area from left hand side to right hand side, this is equal to 1. So a1 is equal to 1. We will have to calculate this area a2, and then we will do again that a3 is unknown to us, so a3 will be equal to a1 minus a2. It is as per the previous problem. How I am solving it for you people. So first of all, you will have to apply the formula. The x is equal z is equal to x is 362 minus 300 divided by 50. You got z value is equal to 1.24. Then go to the book and check the area that has been associated with this, the probability or the area of the z value that is greater than 1.24. Why I am using this greater sign? Because we are interested in the area that is greater than 362, or we are interested in the area that is towards the right hand side of 362, means here it is only in this region. So I'm going to the book. So appendix has been opened. We have to check 1.2 and this 4. So we got 0.8925. So I will write here, it is the area is 0.8925. Okay, so A3 will be equal to, A3 is the whole area, A2 we got this value 0.8925, and the answer is 0.1075. So A3 will be equal to 0.1075. How you will interpret it? You will say that we have the probability that a random variable assume the value greater than 362. The probability is 10.75%. Okay, so I hope you got clear this question. If you've liked my video, please subscribe to my channel. If you have any comments regarding this video, you can do the comments. And further, my WhatsApp number, email has been provided. You can ask me for help anytime. Thanks a lot for watching this video.